So welcome to TOCS. It's our speaker forum that we do on Tuesdays when school's in session at Carnegie Mellon Silicon Valley, and it's open to the public, and we have people from all over the valley and beyond give talks. Today we have and one more thing I want to mention is that we have the microphones these days I'm going to have where you have to push at the bottom of them and then hold it on, the green light on it will be on, and that's how it makes them work. Okay. And please do that when you ask a question because we like to have a good videotape of the talks. The talks are varied, and today we're going to have a very exciting talk to me. It's really an old story of the value of AI being about knowledge representation, and that's something I cared about all my career. Unfortunately, our friend Steve Ray got involved with it later when he really could do something about it, and so there's something called the Semantic Web that's happening now. It's been coming very slowly. Some people that have been patient, like Steve, have been able to actually get something done. And it's only been 30 or 40 years people have been talking about semantic representation. But it is happening. And Steve comes to us by way of NIST, where he worked on standards. He's an expert on optimization in manufacturing. He thinks about uses of semantic web ontology stuff in manufacturing and smart grid. And even in disaster management. So thank you very much for coming today. And next week we will have a speaker from NASA, Ames, talking about his robotic user experience.
Thank you, Ted. And just to expand a little bit about how I sort of came into the semantic world was as part of my many years at NIST working on standards. Ultimately, the world of knowledge versus representation and that technology is a perfect marriage for what documentary standards are trying to do, which is you're trying to clearly and unambiguously define terms and relationships between those terms, and that is the commonly accepted computer science definition for ontology these days, which is computer sensible, unambiguous definition of terms and the relationships between them. So actually, even when I was at NIST, we tried out, and I guess that was about 15 years ago now, trying to define an ISO standard where the definition, the normative definition, was in first order logic. And it worked very well. And this is a standard now. It's called process specification language, written in common logic. It's out there and actually sits as an underlying standard to UML2, Unified Modeling Language. But today I'm not going to really be talking about, I'll make a distinction between semantic web technology and formal first order logic. And certainly in the ontology world, people make a big distinction between those two things. Semantic web technology is much less formal than formal first order logic, but still offers a tremendous set of capabilities and tools that get us a lot further than traditional relational databases in my mind. Some would argue with me, but I hope to make believers out of you today by showing you some of the properties that semantic web technology have that I think makes it very amenable to both big data and distributed data stores, things that you will find more and more often these days out there. So let's go on here. So actually, I pulled this from something I read on the Huffington Post last November, which was trying to predict, technology trends, what's happening, what's going to be big coming up, and these were the list of top 3 that they came up with. I mentioned that only because I'm not going to talk about cloud or natural language processing, but that is certainly, those are all rapidly growing technologies as well, but their top one was semantic web technologies. So this is going to be a very gentle introduction to this. I'm not going into great detail of theory or anything else. First, let me just give you a little perspective on, this is representations and trends in representation over the last quarter century rather. And at that time when I stole this slide from a colleague at Defense Logistics Agency, that bar was sort of dividing the really commercial operational use of things like XML, web services were just getting into vogue, and some of these other things like RDF, Resource Description Framework, and OWL really were still in the lab, if you like. And I would argue that now we're sort of up there, so that's moved into the real practice. There are a lot of commercial systems now that are using OWL for their main representation. Meta models the same as schemas, if you like, and they're meta models as well, which I can touch on briefly, and how those are very useful for moving from one language to another. So RDF OWL is now, I'd say, in the mainstream for a lot of commercial practices. And why is that, is the question. I'm going to go over these 5 main properties of the combination of RDF and OWL, which I would argue makes it so appealing. It's you don't have to have a Ph.D. to take advantage of these kinds of things. It's very amenable and accessible. So let me go through these. Well, I'm going to actually go through them in more detail in the next slides, but you can read them quickly here. And if anyone wants to interrupt, by the way, I'm all ears for questions, because this is not a hugely long talk, so we might as well have dialogue during the talk.
Yes.
Go ahead.
I'm going to be always interested in the brittleness of representations and debugging. So as you can weave that in, I'll be very happy.
So you're worried about brittleness?
I think those are things to worry. Yeah,
oh,
things
great.
that I want to hear about.
Well, this is so flexible, so you'll be very pliable when you're using this kind of stuff. Not brittle at all, but I'll go into that. Okay. So basically, first of all, RDF, Resource Description Framework, takes the very simple grammar, syntax, of everything in the world is storable as a triple, subject, predicate, object. So Steve Ray works at Carnegie Mellon is a triple. So, works at is a defined verb then. And the thing about RDF is they expect, well, they require that at least the subject and the predicate at all times are actually unique identifiers somewhere in the globe of what you mean by that thing. So it's a URI, Uniform Resource Identifier. So that Steve Ray would not just be the string Steve Ray, it would actually be a URI, which for purposes of discussion here we can say maps to a URL, a point on the web somewhere that represents the concept Steve Ray, this Steve Ray, not some other Steve Ray, because there are of course many people with the same string names. So that unique identifier of that concept has then some relationship, some verb, if you like, which itself is a unique identifier. What do you mean by works at? Okay, well, I'm using the, friend of a friend ontology definition of works at. Okay, and friend of a friend is an early social network ontology model before Facebook, but it basically defined the notion of a person and an address and a working location, a phone number, et cetera, et cetera. So I could say in that predicate, works at, pointing to some FOAF, HTTP, blah, 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 definition of works at, what that means. What are the properties? What is it a subclass of, or something like that. And then the third usually also is a URI, although sometimes it's just a literal, like a string or a number or something like that. But it can be, Carnegie Mellon University. The concept Carnegie Mellon University has a unique identity somewhere out there in the space. And the point is now all of these URIs, of course, are pointing all kinds of different places. They're not all in the one database or anything. And that starts to give you a glimpse of how this essentially knits together the world. And you might have heard the buzzword linked open data, which has a lot in common with this in terms of using RDF to relate disparate concepts, people, things, whatever. So everything's a triple. Here's a very interesting one, because if you now assume there are these RDF triple stores
scattered all over the world, you don't know what they're storing or even what the structure is of how they're storing it. But the nice thing about RDF is, since everything is a triple, the data is stored as triples, the schema is stored as triples. So you can actually ask or interrogate, examine any of these RDF stores, and you'll see things like, at the schema level, you know, the class mammal is a subclass of the class animal. I'm writing just words here, but assume these are all URIs, okay, these unique identifiers, and including, you know, the definition of what do you mean by subclass. That would be out there defined. Human is a subclass of mammal, you know, and then at the data level, you've got instances of things, where of course human is the same human as there. Is a type of, an instance of this class human. George is married to Lisa. So what that means is, if you are burrowing into one of these data stores, you can find out what the data store is actually storing at a model level, as well as at the data level. Yes. Yeah, putting the microphone so that people who dial in and stuff. Yes.
When you think of the homonyms and synonyms and spelling mistakes or variations, which always happen.
Yeah.
And are you not pointing to wrong place? Are you not pointing to something that sounds like it? Depending on whether this is done in text or is it in voice.
Oh, it's not in voice.
If it is done, if you did a voice markup equivalent of this,
yeah,
then any comments on it? And each one of these, like Stephen Ray, may have multiple identities also.
Well, that's correct. It may have multiple identities, and any one of these clauses would point to one of those. Okay, so if it's Steve and Ray in his work context, there would be a URI for that, or Steve Ray in his home friends context or something. So it certainly allows for that. I can't help the spelling errors. If you're going to have a spelling error on a URI, it's a spelling error just like a spelling error in a computer program. It's going to not work the way you intended. But again, these are intended to be computer sensible. Okay, this is not supposed to be read by humans normally. This is for machine-to-machine communication.
I'm terrified by you not being able to help me by spelling errors. Okay, and so that's what I call brilliant. And so,
okay,
absolutely. There's always, as he says, there's always spelling errors.
Okay.
So if I want to add a tool that does spelling checking to the system,
yeah,
and automatically fixes it,
yeah,
is there a nice, simple way of adding that into the system?
Yeah, because I'm not describing an application here. I'm just describing the representations. No one typically would ever write these URIs by typing. Okay, so you would almost always have a tool, which might be you select something, which there you don't have to spell it at all. It's just pulled over. So this is just what's under the hood. The faint of heart, you wouldn't want to write this stuff. I don't think so. Only the truly geeky person would actually write this stuff. Okay, so you can explore the schema and you can explore the data all in the same place. It's all in one undifferentiated bag of triples. Okay, now this is how you would explore such a thing. There's a language called Sparkle. That stands for Sparkle Process Protocol and RDF Query Language. It's a recursive acronym, but anyway. And here is where you might do a query against the data. Okay, and again, how this whole query language works is just pattern matching of triples. So this is basically saying, match me any triple in your particular data store you're looking at, which has George, the URI George, the predicate married to, and then anything out there. It could be 5 hits or 1 hit or whatever, no hits. And then hand me back the thing you found or the things you found, one or many of those things. Okay, so that gives you a table actually. I only found one in this example, Lisa, the URI, of course. That's how you query for data. Here's how you query the schema. Same thing. Find me any pattern in this triple store where whatever is followed by the verb subclass of, followed by the URI for animal, the class animal. Okay, and it'll come back with, in this particular case, only one, but of course it'd be many URIs, all which are class definitions for subclasses of animal. That's part of the definition of the class, of course. So the syntax is actually pretty straightforward. Of course, you get these humongous queries depending on how fancy you're trying to be. But again, it's the same query language. So you don't have to have a separate DTD or data schema file or something compared to the data. If you're given a URL for a triple store, right, a location on the web for a triple store, once you got that, you can explore the schema, you can explore the data, all using the same language. So you can imagine one could write, even programs that could go in, find out what kinds of information is there, and then hand you back samples or something like that. Yes.
I'm holding it down.
Good.
If there are long sentences with multiple clauses,
Mm-hmm.
in conjunctive words,
Mm-hmm.
all of them.
Mm-hmm.
How do you handle such a thing? And this is only for English, right? We are talking no other language.
No, it's for any language. It's concepts. This is
Just
semantic.
want to make sure. Other ones may not use the same
Well,
punctuation styles.
yeah, that's actually a good point you bring up, because really, these URIs could be meaningless bits, okay? So try not to get too wedded to the spelling, or I'm writing them as words here so that you guys understand, but it's just all it really is a unique identifier to some thing out there on the web, okay? So it's saying, find me anything that has this unique identifier and this unique identifier related to it. So language, it's whatever you want it to be. You can invent something in some third language. Let's see. Well, first there's a question in the corner, and then I'll get to you.
The question before
Yeah.
scratched right at the edge of what I was going to ask. Thank
Okay.
you for introducing this. Let's consider this data point that George is married to Lisa.
Uh-huh.
We have another data point that Joe believes that George is married to Lisa.
Right.
That's the compound sentence that he
Right.
was
Whoops.
talking about. I'd like to know how you do that.
Well, you would have to invent, just as whenever you're trying to take a higher order logic and representing it in a lower order logic or third normal kind of thing, you're going to have to invent these intersection nodes, B nodes, they call them in RDF. So you invent these intermediate things so that George is married to Lisa. You could say something is a fact representing that, and then you have this person believes that fact. So you just have to, it's the same games you play when you're trying to normalize a typical relational system where you have quaternary or higher kind of relations. So no magic there, same problem. But you have the advantage. Everything's so simple from a syntactic way this way. If everything's a triple, you can start doing all kinds of things. Oh yeah, you had the question, right. Just sort of hold it down. It doesn't move. It just sort of senses you. It's the button on the bottom. No, not the light.
Okay,
There it
hold
is.
on.
You got it. All right.
All right, now I just wanted to say other polls, but when you say these are characters,
Right.
at the same time, since the big part of this, what meaning will be defined by those characters.
Yeah.
For some way there is a description of clause
Right.
married to me.
Right. That's right.
That's like, I understand, very important part of it.
Absolutely.
When you talk about semantics, right?
Right. Okay. Now I'll take it as far as I can take it, and then I'll give you a quote a friend of mine in Texas has. The meaning of any of these terms is defined by the relationships it has with other things. Okay. Ultimately, that's as far as you can go with the computer. So that is the definition of subclass is you go and find out what other relationships subclass has. So, yeah, all right, let me rewind. Okay, first I'll start with my last statement, which is a friend of mine, is a philosophy professor at Texas A&M, who says basically as soon as you write it down, it's not semantics anymore, it's syntax. So his argument is true semantics only resides in your head and nowhere else. Okay, having said that, what we build is syntactic constructs to try and get us to the same kind of behavior as the thing that's in your head. And then by behavior in this sense is what are the relationships of a given concept. I can only define it as, well, it's a subclass of mammal, it lives in Africa, you know, and eventually you're going to define an elephant. But an elephant is defined by the properties it has, the relationships it has with other species, categories, things like that. That is the definition. So the definition of any of these terms is the set of triples it exists within. I also want to say one thing, because this messes a lot of people up, and it messed me up in the beginning too. They made a big mistake in the semantic web with OWL and in thinking of these as classes. They're really sets. When you see subclass, you really should think subset, because each subset, now I'll say, is really a specialization of the thing that it's a subset of. So animal is a set of things that are animals. A portion of that is the things that are mammals, okay? And this is very important when you are trying to transpose these thoughts into object-oriented programming. It doesn't work the same way. This doesn't exhibit some of the properties that object-oriented programming has in terms of polymorphism, of method overloading. There is no, when you think of it, mammals as a subset of animals, well, they're still animals. They still do everything the animals do. They can't say, well, I'm a overloaded version of an animal that no longer breeds or something. No, it's part of the animal class still. So, animal set. I just blew my own thing. So anyway, think set whenever you see class, and it works a lot better. Okay, that really helped me when I finally saw that. Okay, so that's how you query. Now, validate, the reason is because you can not just query, okay? You can actually use, there are basically just 4 basic types of SPARQL statements. One is select, which you saw in the previous slides. One is construct. Construct creates new triples. So this is what inferencing can do for you, right? So in English, if you said George is the son of Fred, Fred is a sibling of Mary, then George is a nephew of Mary. That makes sense. Okay, that's good old. And this is how you say it in SPARQL. Anything that is the son of something else, and that same something else is a sibling of a third thing, then build me a new triple that says A is the nephew of the third thing. Okay, it's as simple as that. And what you will see is you can do all kinds of deduction in a triple store. This violates what relational database people are trained is to try and reduce the database size to third normal form where nothing's redundant, okay? Here you're making a redundant thing because you could always re-infer at some later time. But the semantic web actually likes you to be redundant because you don't know where this stuff is sitting all over the place. And maybe you could have inferred it from a piece of information here and a piece of information there, but you have to know that those 2 pieces of information exist. And that brings up another issue about the semantic web, which is it's designed to be open. This is the open world assumption in AI where you know you don't know everything. In fact, you can't be sure something isn't true just because you're not aware of it. It might be true, and it might exist in a triple out there somewhere. You're just not aware of it. So you can't prove things aren't true. Okay, all you can say to the best of your knowledge is, I'm unaware of such and such, if you're trying to test for that. Okay, so you can make assertions, but you never know what else is out there that could even contradict what you're asserting, of course. So it's an open world assumption, and with all the implications thereof. But the point is, the reason I call this easy to validate is you can actually raise alarms if you discover a couple of contradictory statements. If you can make a query which says, check for this and this and this, and if those are all coming up with something, you got a problem. And you could construct a triple that says, you have a problem with this, or something has a problem, you know. So you can raise concerns, which is, by the way, the kind of thing I do when I'm helping to validate standards. If I turn them into OWL, which is this language, I can run some queries over these standards to find out if there are contradictions present in the standard. And right now I'm working on one where we're finding all kinds of problems with data type declarations in this standard. It's just a mess. But it's easy to find the mess this way because you can examine the entire standard with some query tools, which you can't do in UML. So easy to interoperate. And this is the point which is kind of really very, I think, very cool. You can issue one query which in the same query is interrogating multiple different data stores. So this particular example, and that's the one way to do that is with the service call. You say, okay, this next part, go off to, and there's the URI, or the URL actually, for the data store. And this is going off and saying, I want to check the linked movie database, which is out there in the universe for anyone to explore, and find me all the actors. It says, from this given movie, which happens to be Star Trek, number 675, this movie has actor and then something. Okay, so you're going to get a bunch of triples back with all the actors in Star Trek. Okay, and give me blah, blah, blah. Okay, and furthermore, from the actor has a name, because remember, that's a URI, and the actor name, that'll be a string, the person's name. Okay, then I'm going to go off, and given that name, which is a string, and I'll explain the weakness of this in just a minute, using the English name of the string, go to DBpedia and find me any actor that has a name with the same name. Okay, and if you find one, go off and ask DBpedia for the birth date of that person. So what you've done is the linked database, the movie database, has all the information about the actors but not their birth dates. And DBpedia, at least for famous people, has all the information about their birth dates. So you're essentially doing like equivalent to a join, a relational join. But these two data stores don't know anything about each other. All right, you didn't have to do any kind of building a program or anything. It's just one query, and you get the following people with their birth dates. And those of you who are alert can notice there are two Stephen Collinses, and that is the weakness in this particular way of doing it, which is that we were comparing strings. So one of those is an actor, and one's actually a boxer who shows up in DBpedia, but wasn't in the Star Trek movie. Okay, just had the same name. What would be nice in a truly linked world is actually, and this is starting to happen for DBpedia itself, there's an OWL statement called same as, and it actually allows you to link this URI in the movie database is the same concept, same person as this URI in DBpedia. Okay, and if you have that, you're no longer reliant upon string matching of names. You're actually, someone asserted, or you asserted, that those are in fact the same concept. So if you had, as many people are doing now actually just by societal trends, a lot of people are using the DBpedia entry for a person as the canonical universal place for the concept of that person. So it would be easy enough for the linked movie database folks to start saying, you know what, we should just store another triple with each of these people, which is the pointer, the same as link to the DBpedia, and then I wouldn't have fallen into this trap of the string match. So that's just a matter of time. People are going to start doing that more and more as the world gets more and more linked together. So those of us who are lucky enough to have an entry in DBpedia, which I didn't explain, is all of Wikipedia in a queryable form. Okay, it's a RDF triple store of everything that's in HTML for people to browse. DBpedia is available for computers to browse in a queryable way. So that's how you would do a single query among two data stores. There's no limit on the number of data stores. You've got to worry about timeouts, but the potential for this is then federated systems in a very easy way, because you can just, as long as you know the location of the database, you can combine queries with all kinds of sources. Now let me see where that could lead us. There's DBpedia, and there's actually a site out there that shows a lot of the linked open data stores that are available today to people, and it's pretty big actually. So you have, I just know some of these figures. This is a guy in Germany made this, but there's the whole U.S. Census, all the data out of the U.S. Census. Here's the British government. They're really big into data.gov.uk. We have data.gov in the US here, but some countries have really jumped into this. Here's all the New York Times as a searchable data store.
And the size of these
Already
is
of
how
triples.
big they are?
Yeah, the size of the circles is how big they are. That's exactly right. And the lines are the references, the cross-references they're making to each other. So a lot of these data stores point to DBpedia.
The total number here is what, 10 terabytes? Or what?
Of total amount of storage? Wow, it's got to be more than that. It's got to be more than 10 terabytes in petabytes. All of New York Times, all of this CIA World Factbook, all of DBpedia, all of the U.S. Census results. I mean, some of these are huge data stores in their own right.
And by the way, IBM also used DBpedia in Jeopardy.
Right, right. They made a local cache because they weren't allowed to go out on the internet during this competition. But no, there are truly mind-boggling amounts of data out here. And this is just what's sort of publicly advertised. A lot of people store their things as triple stores, and you can either expose that to the web or not. If you expose it, it's called a Sparkle endpoint. We just built one on Amazon for a project we're doing here for Smart Grid. But so these are all pretty much, not uniquely, they don't all necessarily accept a Sparkle query interface. Some of them you have to browse by hand, but they're all available on the web. So it's kind of fun if you Google linked open data, you'll come across this diagram pretty fast. And these are all clickable. You can just click one and it goes to the home page of that source and explains to you whether it has a Sparkle interface and what it is, etc. Yes?
Is that all government information or any of it?
No. Well, New York Times isn't government. No, there's lots of private stuff in here. This is the DBLP. That's the publications, scholarly publications database to look up people's publications. You could do a Sparkle query to find it. Yeah, it looks like it. Probably, yeah. Best Buy has one of these things, but you have to have authentication to get into it. So they're not all, publicly wide open. But yeah, Best Buy is actually a popularly quoted one. Every single product they have is in a queryable database. I think probably for their stores to query each other through a Sparkle interface. Yes.
Sorry for, but the reason for, I guess, England and also France and Sweden are RDFying all their governmental data is it's becoming somehow European community.
Yeah.
I don't know if it's like a rule, but almost it's a policy. So they spend a lot of tax money to do
right.
that. So that's an
That's
effort for
And,
I think many European countries.
And I think it's for many of the reasons I was just going over, which is it's very easy to integrate these things now. It doesn't take, Booz Allen Hamilton $1 million to integrate 2 of these databases. You can just write Sparkle queries. So it's a very appealing, to me, very appealing, lightweight interface to be able to access data in a form that still is rigorous enough that you can actually do reasoning over it, and inferencing, like I was establishing. So let me, yes.
Easy, what's impressive to me is that the New York Times has put their stuff in this form. If I want to, make, RDLify a data structure that's large,
right?
Do I have an idea of how contained that problem is, how hard it's going to be, how much money I'm going to spend?
Not hard at all. I do, actually, with the tool I'm using. I can take in spreadsheets, or I can take in relational table definitions, XML, XSD files for the schema, XML for the data, put it all into a triple store. There are lots of tools out there that will ingest. Furthermore, a lot of those things you saw in that last diagram, actually under the hood are still relational systems. There's a technology called D2RQ, which I don't know what the D stands for, but it's to relational query. Okay, you can actually put a front end to make a relational system, either MySQL or Oracle or whatever, behave as though it were a Sparkle, a graph store, a triple store. And I was actually just this morning going to try that out, but the guy who was asking didn't give me the URL in time, so I didn't get a chance to try it. I would have had a slide. But you can take a triple store or a spreadsheet and rather make it look like a triple store with Sparkle. Yes.
If there is a sentence like Lisa is 10,
Yeah.
doesn't say 10 years old,
Right.
whatever else it is, right?
Right.
And just a number,
Yeah.
and that's the predicate.
Yeah. Well, I would have said that's not a very good sentence, first of all.
I understand.
Right. Okay.
That's how things are written
Right.
in the real world.
Right. Right. That's right.
Except
Right.
for, grammarians like you and me.
Well, that's exactly right. And that illustrates the whole point. Natural language is very flexible and very ambiguous, right? There's context around the sentence, Lisa is 10, that you're adding in as a human. The Lisa is probably a human, and you don't know what it means until you heard the number 10. Then you say, okay, they're probably talking about age, right? RDF and OWL is all about explicit semantics. You don't want that kind of flexibility. So the appropriate RDF triple would be something like a URI for Lisa, a URI pointing to something like has age, which is out there in one or more ontologies actually, including has birth date, you can infer it, and then 10 could be an integer still. That's fine because has age could have a range of integer.
What about all the punctuation? Now,
What punctuations?
Oh, if
You're
it is
saying
a
taking
question
it-
mark,
We're getting a little detailed.
Yeah.
So I want to get to this topic.
Yeah, basically, but to convert from a natural language world into an explicit semantics world, you have to make the semantics explicit. Okay, so that's the whole point because you don't want computers to have to use common sense because they don't have common sense. So the whole thing about formal semantics, whether it's semantic web technology or first order logic, is it's explicit, excruciatingly pedantic to some, but the whole point is to avoid misinterpretation on the reader's end. Yes.
Can you explain, some of these data stores have many more links to them?
Yes.
On the right, why would that be?
Well, for the same reason that if someone is talking about a human and they want to identify who is that human, they might point to the DBpedia entry for that human. So there's a reference to. In other words, this data store has a reference to some URI that resides in this data store. Okay. So, yeah, that's exactly right. And so you see the little local. Is that the DBLP? Yeah. So that's a lot of people reference scholarly publications out of DBLP. Okay, including the Association of Computing Machinery over here, right? They'll make cross-references to DBLP. So you can sort of read the acronyms if they make sense and sort of figure out, CiteSeer, DBLP, and ACM, there's a reason why they happen to be located together here because they're all talking about publications. Oh, the red circles were just me highlighting a few that people might be aware of: New York Times, World Factbook, the U.S. the British Transportation Department Census. I was just highlighting that for the talk. Yes.
Well, just to be clear, regarding how easy it is to create a triple store, I mean, part of that work is designing the ontology.
Absolutely.
And perhaps that's well, I wouldn't say that's always the biggest part, but that's a significant intellectual
Absolutely.
effort.
Yeah, no, that's the challenge. It's just like knowledge acquisition in AI days. You got to get that ontology right if you want it to work right. So you're right. A lot of people spend a lot of time designing ontologies, and actually mapping from my standards world. All a standard really is an ontology for how things should be represented or transmitted. Okay, that's why it works so well. This kind of stuff works well for standards. You can map them in because it's just talking about definitions and relations of terms. And yet, most standards are in natural language, which really sucks, actually, as far as being unambiguous. So that's why I'm a fan of that. Am I supposed to stop soon?
No, I want to make sure that you have the freedom to get through your
Oh,
slides.
yeah, I only have like 2 more slides.
Oh, that's great. And then we will have time to talk outside too. But we have 15
Okay,
minutes. Yeah,
good.
no problem.
All right.
It's
So
up to you.
I'm
I just
enjoying
wanna- I just
the.
want to support. That's great.
I'm enjoying the dialogue.
Okay,
Yeah.
so you just drive it.
All right. All right. So implications then is that I'm suggesting that What did I say here? Native for translation, one line. All right. Oh, wow, that was left over from another time I gave a variant of this talk, but it was a company that was actually doing models of product and process, CAD models and things like that, it is a very flexible, it can be used for that, it can be used for any of a number of different applications, obviously. It's just it's agnostic as to what the domain is, but it is very flexible. It's got this API, which many modeling languages don't have an API. They don't have a query language that supports it, okay? And that's a big win. And again, the storage, it's completely agnostic as to whether it's querying a local data store or something out of the web. In the query, it's where am I looking? Local host or HTTP something else. So it really doesn't care. I do all this because I work in interoperability, and I see this as a tremendously powerful tool to aid in interoperability with a relatively low cost point. It does not require systems building in the traditional writing code sense. If everyone's just using this fairly simple-minded triple store idea, it really makes a lot of these problems go away that otherwise exist in terms of these kinds of things. So that's why I'm a fan of it as a consumer. So I'm not a technology pusher. I'm an enthusiastic user of this technology because of the payoff I get whenever I apply these kinds of things to the problems I'm dealing with. So I think that is indeed my last slide. So we can now have open-ended discussions. Thank you. Quick drink. Yes, there's a question.
So just to play devil's advocate, regarding interoperability, you could say that, well, if you had a Microsoft SQL server, if everybody agreed on standards for SQL databases and they were queryable over the web, that you would have, a similar kind of effect to what you get with triple stores.
Well,
I just wondered whether you could sort of compare and contrast.
Okay, one comparison is that any relational system stores the schema separately from the data. So that's one thing you win here. You don't have to call someone who's the database operator and say, could I please have your schema document so I can understand what these numbers or strings are. You can query to find out what the numbers and the strings are. So that's one thing which is already a big barrier because you may not know who to contact. Even if there's a SQL database out there, how do you find the documentation about it? This is self-documenting in that sense. Okay, so that's one difference. It is true that performance-wise, I would argue relational databases have had so many years of tuning and performance improvement, you're going to get more throughput out of a relational store. And that actually is the reason when some people actually recommend don't move your data out of the relational store, put this D2RQ API on the front. And then you get all the advantages of the flexibility of Sparkle without any of the disadvantages of sometimes you get a hit. Another angle to keep in mind, because it's not a panacea for everything, if you have, I'd say RDF and triple stores, it's a graph database. So the increased interest these days in NoSQL kind of data stores, graph stores, is when you have sparse data that you want to use a navigational paradigm to explore, as opposed to a dense data store, which a relational table is really good for. If you have a fairly simple schema and just petabytes of data, relational systems definitely the way to go for that. Well-defined fields, well-defined relations, but if you're more into discovery mode and browsing, navigational browsing, a graph store, I'd say, is better for that. So yeah, you've got to balance the pros and cons. For the reason I guess I'm come down on this side is because these days the world isn't getting any simpler, and people aren't, in fact, walking the same tune as anyone else. So my basic premise on systems integration is every system that needs to be integrated is almost guaranteed to be different. And almost no two systems are really going to conform to any given standard very often, which means you got to do mappings instead. And you can do mappings very easily with SQL, with Sparkle rather. So I'd rather have things stored in their native places, and you use a distributed query language like this to pull when you want to, as opposed to trying to take a whole data store and now how can I mash that into this worldview? Everyone's context is different, so let them live in their own context. Now that means when you're trying to use the information, of course, you have to be aware of that contextual difference. But yes, when back then you, Ted.
Yeah, I want to ask, so this can certainly lead into data mining that we're hearing about in the news and such. Can you talk a little bit about some of the, maybe some of the things to watch for when data mining, trying to find things that are related but maybe not, maybe getting data wrong? Talk about that a little bit.
I'm no data mining expert, so I probably can't give you any pointers there. In general, in my experience over the years of doing data modeling and all, it's the unstated assumptions that get you in most trouble. Certainly when I've been doing systems integration in the past, people just assume, I'll take a manufacturing example. I used to work in manufacturing. You know, people say something like delivery date, and there's contracts based upon delivery date and getting something on time. But what exactly does delivery date mean? Does it mean the date the shipment was sent, the date it arrived at the loading dock, the date it signed off by the receiving officer, or something like that? So no one writes that down, and people go along their business with different interpretations of those words. That ultimately comes back to haunt people with interoperability problems. Yes, Ted?
Yeah, I just would like, if you can think of it, 2 or 3 success stories. You know, what the problem was, what happened, maybe some glitch if it happened, and then wow, this is really changing everything for these people. Is that possible?
Well, I'd say some of the success stories were on that diagram in terms of the New York Times making its data available and queryable, DBpedia, not Wikipedia, but DBpedia, as a resource now that all kinds of these other data stores depend upon as something that's there, available for reference. These are, now in my own personal life, the success story is this standard I'm working on in the smart grid, where I have sucked in an OWL representation of the standard, start running queries over it, and discover 5 different ways that energy is represented, data typed, kilowatt hours, KILOWATT hours, or KWH, or in one of the examples, kilowatt, which is wrong. It was, you know, that's a unit of power, not a unit of energy. Those popped out of the queries. So it's a very easy way to, because some of the standards we worked on had 10,000 class definitions. Okay, you're not going to manually find contradictions in such a standard manually.
So I love that last example. That is a place where it being that representation helped you have a success
Right.
at debugging the database itself.
Right.
I'm thinking of something that's happened for the New York Times population because it's in RDF, or happened for some community now that it's in this great format. Including, you know, I mean, you've got the great ones of interoperability. There's implicit in your diagrams, huge success.
Yeah.
However,
You want a couple of good stories.
A story.
I don't have some good stories like that, but I should look some up, I think. So the next time I give this talk, I could...
Maybe somebody else in the room has one. I don't know.
Yeah. Yes, sir.
I think that IBM Watson is a good example because they based their knowledge on, I mean, they have their own internal representation while it's playing, but
Right.
it's based on DBpedia.
Right.
I did a presentation about the semantic service, the databases that are RDFI'd, and so they are of course on your slide there, but WordNet is a
that's true.
very good one, which describes the English language. Music Brains, what else? GeoNames. GeoNames is
That's right, GeoNames, yeah, for geospatial.
what else? Freebase.
I think...
when I did the presentation, the DBpedia had 1 billion triples. That was a couple of months ago.
Right. 1 billion, yeah. Now, actually, Franz Inc., which is just down the way from here, they're an RDF triple store vendor, And they're now advertising they've got the technology to store 1 trillion triples, which is pretty amazing, actually. They'll give you 50 million triples for free, by the way. The free download supports 50 million. So.
I'm co-chairing a WSRC group called Media Annotation Work Group.
Okay.
And we socialize a lot with Semantic Web people.
Yeah.
And I'm aware, maybe you're aware, that there's a work group starting called Link. It's about LOD.
Oh,
The Linked Open Data work group is starting.
Yeah.
It just posted a charter a month ago.
Yeah, I mean, one of the names that pops up on the linked open data world in this country is Jim Hendler. He's at RPI now, and he took on the task of taking huge amounts of government data on the Open Government Program initiative and turning them into triple stores, basically. So I think he was behind a lot of those census, things like that. So I think ultimately it's it's not a single story, but it's the fact of turning data from human-readable HTML files into machine-processable, queryable data is the real killer. And I've gone on record in the past as claiming that as much as the World Wide Web transformed the way we as humans get information for our daily lives, the business world has yet to really experience that same kind of revolution, and it's poised to do so, because the business back-end systems and stuff, they don't understand HTML pages, but they can understand SPARQL queries. They can understand relational or distributed data queries. So the kinds of savings and productivity improvement in store for machines and the business world, I think, will ultimately dwarf what is done to society and as humans reading World Wide Web pages. So from an economic perspective, I think there's still a huge amount of change to take place once this stuff is codified this way. So that's my prophecy for the future. Okay. Well, thank you very much.
Great. Please join us for some sodas and
Cookies, yeah. Sure.
Intriguing thing. What sort of things do you think in the business world, besides pricing and sizing of goods and manufacturing?
It's like the inventory, the warehouse inventory systems, and the other companies' ordering systems. They start to negotiate directly. Okay, so it's not a human catalog anymore. It's a dynamic products catalog, which is interrogatable by.
Somebody needs a part to build a system of some sort, and they can look anywhere.
Well, I used to do a lot of work with the automotive sector, and one thing that they're going to realize huge savings is what they call supply chain visibility or transparency. They don't want to know just what their first-tier suppliers' inventory is. They want to know what their third-tier suppliers' inventory is. There's a thing called the bullwhip effect. Actually, Professor Stanford had invented that term, which is slight fluctuations in market at the top level, at the OEM level.
Can we move
Cause huge fluctuations in orders and inventory. Your stuff 3 tiers down. Oh, you got.
See, I'm trying to drag people out of the.
So any business transaction, basically.
There's sodas for other people. That's right.
ಹಲೋ ಏನಿಲ್ಲ ಇದು ಇದು ಎಲ್ಲ ಮಾಡಾಗಿದೆ ಅದಕ್ಕೆ ಮತ್ತೆ ಕಲಿಸ್ಬೇಕಾದ್ರೆ ನ್ಯೂಸ್ ಎಲ್ಲ ಹಾಕಿದ್ರೆ ಏನು ಮಾಡಬೇಕು ಚೇಂಜ್ ಮಾಡಬೇಕಾ ಸುಮ್ಮನೆ ಹಾಕೋದಾಗುತ್ತೆ ನ್ಯೂಸ್ ಎಲ್ಲ ಹಾಕಿದ್ರಲ್ಲ ಮತ್ತೆ ನ್ಯೂಸ್ ಹಾಕ್ತಲ್ಲ ಓಕೆ ನೀವು ಸೇಮ್ ಆಮೇಲೆ ಓದ್ಬೇಕಾದ್ರೆ ಹಾಕಿದ್ರಲ್ಲ ನೀವು ಇನ್ನೂ ತೆಗಿಬೇಕು ಜರೂರಿಲ್ಲ ಫರ್ನಾಂಡಿಸ್ ಬಗ್ಗೆ ತೆಗಿಬೇಕು ಹಾಗೆ ಬರದೇ ಗೊತ್ತಿಲ್ವಾ ಹಾಗೆ ತೆಗಿಬಿಡ್ಲ ಗ್ಯಾಪ್ ಹಾಕಿರ್ತೀನಿ ನೋಡಿ ಅವರೇ ಗಿರ್ಕಿ ಆದ್ರೆ ಕಾಲ್ ಮಾಡ್ತಾರೆ